Hello, exceptional students of Mrs. Whitney's, and welcome to the final section of Unit 4, Section 4.4. This is solving two-step inequalities, and this is kind of where we put everything together. So let's start with an example of 5x. I was writing 5x subtract 4 is less than or equal to 11. So we're going to add 4 to both sides, right? Because the two-step equations, you undo addition or subtraction. So since subtract 4, we're going to add 4. We're going to add 4 to both sides. Negative 4 plus 4 is 0. So we end up with 5x is greater than or equal to 15. It's 5 times. So we're going to undo the multiplication or division. So since it's 5 times x, we're going to divide both sides by 5 to undo the division, because 5 divided by undo the multiplication, because 5 divided by 5 is 1. So I'm left with x is greater than or equal to 3, because 15 divided by 5 is 3. If I graph that on a number line, I'm going to put 3 in the middle, 4, 5, a couple numbers on that side, a couple numbers on this side. So it's greater than or equal to 3, so it can be 3, so it's a solid dot. And it's greater than, so that means it's going to the right because these numbers are greater than 3. 4 and 5 are greater than 3. So the graph looks like that. All right, let's try b divided by negative 3 plus 4 is less than 13. So the first thing we do is undo the addition or subtraction. So we're adding 4 here, so we're going to subtract 4 from both sides. We end up with b divided by 3 is less than 13 subtract 4 is 9. Now it's b divided by negative 3, so I am going to, if it's division, I'm going to multiply both sides by negative 3, because negative 3 divided by negative 3 is 1. So that'll leave us with the b. So multiply negative 3 on one side, we have to multiply it on the other side. So negative 3, those cancel out, and left with b. Negative 3 times 9 is negative 27. Now remember, since I divided by a negative number, I'm going to swap the inequality. So it becomes b is greater than negative 27. So I multiplied by a negative, so swap the inequality. Swap the inequality. If I were to graph that on a number line, I'm putting negative 27 in the middle, negative 26 on this side, negative 28 on this side. It's greater than, so it's an open circle because it can't be 27, or negative 27, and then I go this way because these numbers are larger than negative 27. All right. Okay, so graphing an inequality, what graph represents the solution of negative 7 times the sum of x plus 3, which is less than or equal to 28. So there's 2 ways I can approach this. I can distribute the negative 7 times x and the 3, or I can divide both sides by negative 7. As long as I divide the entire side by negative 7, it'll work out. So if I've got negative 7 times the sum of x and 3 is less than or equal to 28. So I'm going to divide the entire side by negative 7. I'm going to divide this side also by negative 7. So these guys cancel out, and I'm left with x plus 3 is less than or equal to negative 4. Now I am, actually, wait a second. caught myself in an error here, right? Since I divided both sides by -7, I needed to swap the inequality. So I have to change that so that it is greater than or equal to. Okay, now I can carry on. Since I'm adding 3 to the side, I'm going to subtract 3. So that will leave me x as alone. So x is greater than or equal to -7, and that's my answer. So I have to find which one is that, and it looks really hard to tell the difference between the closed circle and the open circle. But I know I want a closed circle because it's equal to, and I think it is, I declare these top ones. These are the closed circles. So I want x is greater than -7, so I'm going to make sure that oops, whoa, what happened? I got stuck. I need to undo. Whoa. Let's see here. Undo all of that. Wow. Okay. I'm going to make sure that this is a closed circle and that I am going in this direction. So it is x is greater than or equal to -7. Yikes. Okay. So now time for the real life application. So you're renting a moving truck for a day. There's a daily fee of $20 and a charge of $7.50 per mile. Your budget allows for a maximum total cost of $65. So you can write and solve an inequality that represents the number of miles you can drive the truck. This is very much like Mrs. Burke and myself when we did the Mrs. Burke Buys a Horse. So there's a daily fee of $20. So this only happens once. So it's $20 plus the 75 cents per mile. And that happens as many miles there are, but we don't know how many miles. So that means it is 75 cents times the number of miles. And we know that we have $65 to spend. Now this amount has to be less than or equal to, right? I can't go over 65. This is the most money I have. So it's $20 what happens once, 75 cents that happens as many miles as there are, which is less than or equal to $65. Now we can just solve it as a two-step inequality. So I'm going to subtract 20 from both sides. I'm left with 75 cents per mile is less than $45 as I subtracted off the $20 of the daily fee. Now I'm going to divide by 75 cents. So I have 45 divided by 75. So let's see here. 45 divided by 75 cents is 60. So the number of miles has to be less than or equal to 60. That's the number of miles that I can rent, that I can move. So I need to look for an apartment that is within 60 miles. Thanks for watching.